But let's go ahead and continue here. I'll read it out loud for all of us. Suppose you are buying two kinds of notebooks for school. One's a spiral notebook, and that costs $2, and a 3-ring notebook, which costs $5. You must have at least 6 notebooks, and the cost of the notebooks can be no more than $20. So you have a budget of $20, but you also have at least 6, maybe 7, maybe 8. So we have to figure out, what does at least mean? What does no more than mean? And we see that we are dealing with spiral notebooks. I don't like to use the S as a variable because my S's look like 5s too much, or my 5s look like S's. So I'm going to say P here for spiral, second letter. Then I'm going to choose T here for 3-ring. So just to clarify, P is equal to the number of spiral, and T is equal to the number of 3-ring. Okay, next we have to figure out what type of equations, or inequalities in this case, we're going to be building. So notice, I have a limit right here. I have a limit. The lowest I can go is 6. And it says total number of notebooks that I have. Okay, so that means when I take P and add it to T, I should have at least. So let's get to that real quick. What does the word at least mean mathematically? At least is going to be a greater than or equal to, because I can choose 7, I can have 8, I can have 9, 10 notebooks. Okay, so that means, quickly speaking here, no more than is going to be less than or equal to. That's the total. My total budget is going to be $20 or less. So let's finish this up. When I take the P and add it to the T, I'm going to have at least 6 total. Now the other one is talking about costs, right? So the spiral notebook costs $2. So that's going to be the cost of how much money I spend on spiral. And the next one is $5, and that's going to tell me 5 times T is how much I spent on 3-ring. And I have an upper limit. I can't go higher than 20. So here is my system of inequalities. Now, before I attack the graph, or at least getting my correct forms, I'm going to choose over here which is going to be my independent and which is going to be my dependent variable. It's sort of random, but I'll just put the number of spiral down here. Since they're officially neither of them are dependent on the other, it doesn't actually matter which you place which. And this one's going to be the number of 3-ring. Notice you could also just go alphabetically too. Notice there's my P down there, my T up there. Okay, now to graph. Choose whatever method you want. In fact, maybe for this one, I'll choose slope-intercept form. If I chose slope-intercept form, I have to solve for T. Slope-intercept form. So T is greater than or equal to negative P plus 6.
So how can we use 25?
So the question was, why did I use this 2 and this 5? $2 per notebook. Cost there, $5. All right, now the other one, I'm just going to cross out and use the intercepts. And let's see, practically speaking, what does this mean? If I only buy spiral notebooks, I can buy 10 at the most. If I only buy 3-ring binders, then solving this one will say, the most I can buy of those is 4. So there we go. Now I just have to attack, kill, destroy the graph here. Notice I'm not going to go at all into the negatives, so I'm going to keep on the axes here. And looks like I'm probably going to count by ones, etc. So 2, 4, 6, 8, and 10. 2, 4, 6, 8, and 10. I hope you have a minimalist approach. Please don't put tons of numbers down here, lots down here. The less that you can put in the background, the easier it will be to read and interpret things. So my red line talks about, and I did it in point slope form. So I'm going to start at the 6 and go down 1, right 1 each time. And notice according to this, it's going to be a solid line. Also notice I'm not going to draw arrows on the ends because I'm not going into the negative territory, practically speaking. Officially, I probably shouldn't even connect the dots. Why? Because I can't have I can't have 1.5 notebooks here. But for the sake of this problem, to solve it, we are going to connect the dots there. And now the blue, I'm going to start, the highest on the P I can get is 10. And the highest over here I can get is 4. So when I connect the dots there, I get this. Something like that. Now, of course, we have to ask ourselves, which direction do we shade? The blue is my budget. I have to stay under my budget. The blue, I have to stay under my budget. The red is my notebooks, and I can have extra notebooks, so I'm going to go above that. So in graphing and then shading, I'm going to shade here in this triangular region. So what does that mean? How many different types of notebooks can I purchase? So notice this is one of my solutions. It works. So if we were to interpret that, don't just say 6, 1. We could say I can buy 6 spiral and I can buy 1 3-ring. Okay? All right, so if we pick this point right here, which is 5 spiral and 1 3-ring, it looks like, let me just double check to make sure that works. A 5 and 2, thank you. Let's just make sure mathematically that works. 5 of these would be $10. 2 of these would be $10. And 10 plus 10 would be exactly 20. So I would actually meet budget there. Notice there's another option here. I can just buy only spiral notebooks. So I can buy 6 spiral notebooks and 0 3-ring. Now that probably is not what I'm going to do, but it's an option at least. And correction there, 7 spiral. So today what we're going to do is spend some time solving a system. This time our system has an absolute value. So let's refresh absolute value stuff. And here's my basic form of absolute value. And it tells me 4 things. The sign in the front tells me whether it opens up or down. We also know that this absolute value, it has to be a V or a rooftop, like so. The A, whatever that is, tells me my slope. I put that in quotes because it's not a perfect analogy. The opposite of what I see here is my H. Outside here is exactly my K, and together they form the vertex. Now that we have that review, I can take a gander here. First off, this one here is a linear. So I instantly know it's going to be a line. No bounces. This one here has an absolute value, so I know it bounces because it has a positive A in the front. I know it's going to open upward. On top of that, the A is 1, which means my slope is 1. Up 1, right 1, and up 1, left 1. Next, my H here is a positive 4. And notice there is nothing written on the outside of the absolute value bars. So that is going to be my K there. So here is my vertex, where to begin. This tells me how to move, and this tells me where to move, up. Starting at 4, 0, I'm going to move up 1, right 1, and up 1, left 1, always in the upward direction. So if I did a quick sketch, that's the ugliest ever. I'm going to start low and go like this for my linear. I am going to do dashed on that. And the other one, I am going to start at 4, 0, right there, and bounce there. I'm going to bounce there. So now I know where to focus my attention. I'm going to focus my attention in this region here. So notice that my origin is going to be slightly shifted. So it's not going to be crosshairs in the middle. So let's go ahead and do that, setting up your graph like so. Throw in a bunch of some numbers, not too many. Keep it simple, like so. And now we start to graph it. The first one is beginning at the -3 and goes up 1, right 1. And we're going to have a dashed line because of the less than symbol. The next one, we already said it starts at the 4, 0 right there. And it's going to go up 1, right 1, but also up 1, left 1 from its initial point or the vertex. And let me see what symbol it is. Because of the equal to, I'm going to have solid line, like so, and there. The last thing we have to analyze is of all the regions, notice the regions. I've got this what looks triangular over here. I've got a triangular region up here. I've got a sliver here. And I've got this irregular shape here because it's got that little divot or the corner to go around. So of these regions, 1, 2, 3, or 4, which one am I going to, or ones am I going to shade? Well, it looks like I'm going to go above the V, but below the line. Above the V, but below the line. Above the V, below the line puts me right here. So we've chosen a point that's inside in the region. So 4.5 and 1. So I'm going to put the 4.5 there and the 1 there. So the check is this. So the 1 is less than 4.5 minus 3, and I'm going to put a question mark there. 1 is less than 1.5. Check, got that one. And now check the next one. 1 is greater than or equal to 4.5 minus 4, question mark. 1 is greater than or equal to 0.5, fix that, 0.5, and that's a check. Now remember, this does not tell me 100% that I am right. It tells me I'm probably right. At least that point is in the region, and the only region, according to my graph, is that. I could have messed up on accident and shifted things around. So that's why I just go back and double check my slopes, check my intercepts, etc.